We're going to get started on the next section, which is still going to be using that Gaussian elimination that we've been doing from the first section. But in this one, we're going to talk about like specific cases where when you start to do the elimination process, something happens within your matrix when you start to like combine rows that everything kind of zeroes out, or you get something that's all zeros where like the X, Y, and Z would be, and then you have a number. And so we're going to talk about the difference between those and when we consider something to be an inconsistent solution and when we consider something to be dependent, and what that looks like when you're doing this. So I'm not really going to throw in anything new as far as like the process that we're doing these problems. We're still going to write out our augmented matrix. We're still going to be doing our row operations to try to get our diagonal to be a 1. We want those zeros to start to show up. But as we do these today, we're going to start to see like special scenarios are starting to pop up. And like, what does it mean? So the first thing I'm going to show you is an example of something that would be considered inconsistent, which means that there would be no solution to this. So this is my system of equations that they give me. Now, when you look at something like this, you don't know if it's no solution by just glancing at it. If this was more of like a 2-variable equation, we wouldn't have to use a matrix. There'd be faster ways to figure out if it didn't have a solution to it or not. This one, though, like last chapter, if you had been given a problem like this, you would just have to start solving it and like see what happens. And maybe something would show up with your X, Y, or Z that would cause you to think something about this problem isn't going to work like the other ones do. I'm going to show you how to do this using the matrix. Okay, so we're going to start by writing out our augmented matrix. Remember, that's when you grab your coefficients in front of your letters, you draw that bar, and then you grab those constants after the equal sign. So my coefficients for that first equation would be a 1, a -2, and a -1. And then my constant would be -5. And I'm going to keep doing that for the other ones. My goal is still to get my diagonal to be 1. So these numbers here, I ultimately would like those to all become 1s. And then I would like to start to make the 2, the 3, and the -4 become a 0. Now, because my first number up there in my diagonal is already a 1, then I can kind of skip over that, and I'm going to focus on trying to get this 2 to become a 0. So what's a row operation that I could do to my matrix here to make my 2 become a 0? And maybe use row 1 to help you. Maybe. Okay, -2 times row 1, and then we would add it to row 2. Okay, so -2 times row 1, and then let's add that to row 2. So row 1 stays the same, so I'm just going to copy that down. Okay, row 2 is going to change here. So I'm going to do the math. I'm going to take -2 times 1, which is -2, plus the 2, that becomes a 0, which is what we wanted. -2 times the -2 from up top is going to be 4. 4 plus that -3 is 1. So even better that that came out to be a 1 because I wanted that to happen too. That just wasn't my focus right now. Then I'm going to take -2 times -1, which is +2, plus -1 would be 1. And then for my last column, -2 times -5 is 10. 10 plus 0 is 10. So there's my new row, and then I'm going to copy down row 3. Okay, so I've got my 1, my second term in that first column is a 0. How can we make this 3, this is going to be my next focus, how can I make that a 0? Yeah, and so I'm going to write out here, we're going to take -3 times row 1, and we're going to add that to row 3. So rows 1 and 2 are going to stay as is. Okay, so now I'm going to start doing this. So negative 3 times 1 would be negative 3, plus 3 is 0. Negative 3 times negative 2 is 6. 6 plus that negative 4 would be 2. Negative 3 times negative 1 is positive 3, plus negative 1, going to be a 2 again. And then the last column, negative 3 times a negative 5 would be 15. 15 plus 1 would be 16. Okay, how could I make this 2 become a 0? Yeah, let's just add it to row 1. So let's do row 1 plus row 2. Yeah, I'm sorry, that's what I meant to say. Row 3. Let me fix that. Okay, if we do that, 1 plus 0 would be 1. Negative 2 plus 2 is 0. Negative 1 plus 2 would be 1. And then negative 5 plus 16 would be 11. Okay, so I got that 0 there, but now I'm kind of stuck again because I need to go and make this a 1. Or, sorry, I got to make this one a 0. So let's think about how we could do that without impacting my 0 in the middle there. The other thing we could do is to avoid this completely, if we just back up our step here, instead of doing row 1 plus row 3, what if we took the second row times a negative 2 and we added it to the bottom row? Because then the zeros would still be 0. So I'm going to back this up right here. I'm just going to change my last row. I'm going to change this to taking negative 2 times row 2. And then I'm going to add it to row 3. Because then if I take negative 2 times 0, that's 0, plus 0. That won't impact that number at all. And then if I keep going here with this, negative 2 times 1 from row 2 plus a 2 would become a 0 there. But the same thing's going to happen on the next one. So this is also going to be 0. And then what's this last number going to be? Negative 4. Now, this is what I was talking about. This is like a situation where when I see something like this show up, my X, my Y, my Z, they're all gone on that bottom row. That's an issue because right now what this is saying is that 0 is equal to negative 4. Is that true? No, this is not a true statement. They even have it written down here. This row here could be rewritten like this. 0x plus 0y plus 0z is equal to negative 4. That's not true. So when you get to something like this where something weird like this shows up, and even if we had kept that step that we started with originally and we had eventually gotten there, we still would have ended up in this situation where something would have caused that entire bottom row to cancel off. There's no way to remedy that. Like, I can't fix this no matter how hard I try. So if that shows up and you get a not true statement down there where it's not 0 equals 0, it's 0 equals some other number, it's going to mean no solution. Okay, so that's one of our situations of it's kind of not going to work out like we did before, where we're able to continue to work with our matrix and solve for our X, our Y, and a Z. This one is the no solution case. Okay, if you guys turn the page, we're going to do another one, but we're going to talk about the dependent case now.
Oh, could you send it back direction? As in foods.
Oh, okay.
I think she said she would have that, or she just gave me this in case.
Okay, let me change.
No, you're good. Yeah, but some also gonna help get my reading if I have a turn. Yo, I sold a pack, bro. We made a huge mess. We all had to stay clean. Wait.
Okay. So like I was saying, this one's going to be a little different in that it's going to be a dependent situation, not no solution. Okay, but something similar that we just saw is going to happen. Let's begin by just making out our matrix. Again, we're going to grab all those coefficients and our constants. So this one says 1, -2, -1, 5. What would the next row say? Good. And the last row? Good. Okay, again, remember, end goal here is that I would like these numbers to be 1s, and I'd like those other ones underneath them to be 0s. I already have a 1 in that first corner, so I don't need to worry about that. So let's figure out a way to make this 2, this number, is what my focus is right now. I want to make that a 0. What do you guys want to do? Could you do the top row too if you wanted to? Yeah, you could use the top row or you could use the bottom row. Okay, you're going to multiply by -2 and then add it to the middle row, right? Okay, I'm going to just use the top row, but if you want to use the bottom row, your numbers will change slightly from mine. So I'm going to use the top row here. I'm going to take -2 times row 1 and then add it to row 2. And I'm only doing that because that's what I did when I filled this out myself. So keeping us on track. So row 1 stays as is. What would my new second row say? 0. Mm-hmm. Yep. Good. Okay, and then my bottom row stays the way it is. Okay, how can we, my next target is going to be this 1. I want to make that a 0. How could we do that? Take row 1 times -1. Could we just subtract the rows? That might be a little faster. Instead of having to like multiply by number, we could just take row 1 minus row 3. So what would my new bottom row say? Hold on, watch. What did you say the middle one was? Negative, +1? Yep, 1, and then -5, and then the last number 4. Okay, and then I'm just going to fill in the rest. Okay. How could I make this become a 0? So my first 2 rows stay the way they are. Oops. Too soon. What's my new bottom row going to say? if I do row 2 plus row 3?
0, 0, 0, 0.
Yeah. Okay, so this is slightly different than the last one.
It's still no solution.
It's not no solution this time because this is saying 0 equals 0. Is that true this time?
Oh, yeah.
Yeah, this is true. Now, the last one was no solution because it was false. We had 0 equaled like a -4, I think. So that's not correct. So this is saying down here that this last row is, again, 0x plus 0y plus 0z equals 0. Okay, so this means that there's actually an infinite solution out there. Now, when that happens, we're like that bottom row is gone. What we can actually do is with those top 2 rows, we can create a new matrix with those. So you'll see down here what they've done is they've taken these top 2 rows, the 1, -2, -1, 5, that row 1 and row 2, and they're writing it down here as a new matrix. So they're just grabbing all those numbers down. Now, the reason why they're doing that is because they still want us to maybe think about solving this for my other variables. Now, we're not going to get like a number for these ones because there's an infinite number of solutions out there. But if I'm trying to maybe figure out numbers that would work, I would want to have smaller, simpler equations to be working with, especially if I had to start putting this out there on a graph. So what they did is they wrote out those numbers in my new matrix. They then put them back into an equation form. So remember, this top row would mean it's 1x minus 2y minus 1z equals 5. That's what they wrote right here. And then the bottom one doesn't have an x, so they skip over that and they say 1y minus 5z equals 4, and that's what they have written right here. So what we're going to do is almost think about how could we solve these equations for the variables so that we can still write out a system of equations. Now z, when you have this situation where it's infinite, z is just going to be z, always. Okay, so you can see down here in my answer, z is just kind of hanging out by himself down there. He doesn't have anything fancy attached or after him. Now what they did with this equation, the y minus 5z equals 4, they just solved that for y. What did they just do? Yeah, you just added the 5z over. So this 5z plus 4, they put that in place for the y down there. So instead of saying x, y, z, it says 5z plus 4 for my y term and then the z for my z term. We're just rewriting my x and my y for z. And then they did the same thing for the top one. They took this equation here and they rewrote this for x. Now what they also were able to do, because we have something for my y, they plugged this in here because we don't want to have something that's got a lot of letters. We're trying to write them all in terms of z. So when you solve for y, we can just plug that in here. That's all that they did. And then you distribute, they simplified it, and they got this expression to come out. And that's what they wrote there, that 11z plus 13. So when you have a dependent system, like I said, usually what happens is like that bottom row is going to zero itself out. And then you're going to go kind of backwards and work your way to figure out how do I write my x and my y term in terms of the letter z. And then I write my answers like that. Okay, so we're actually going to practice this kind of method again. We're not going to do a whole thing from the get-go, but we're going to look at this kind of situation here where we've got 2 systems of equations, not 3 this time, and how we could maybe get to that point that we just talked about. Now we're going to use a smaller version of our matrix, so we're not going to have this big, huge, like 3, rows and 4 columns. We're just going to rewrite it with what I have here. So what would I be putting in my matrix based off of this system up here?
1, 2, 3, 7, 1, 1, 1, 6.
Good. Now, to make this simpler on me, it would be nice if I could get rid of a letter. So let's, on that second one, how could I get this 1? That's in my x term right now. How could I get that to go away and become a 0? Subtract row 1 and row 2. So let's just do that. So I'm just going to write right here, I'm doing row 1 minus row 2. Top row stays the way it is. What would my new bottom row say?
0,
Mhm.
1, 2, 10.
10. Good. So now I'm going to go back to working with my equations. So I only needed that matrix to help me get to something simpler by just getting rid of that x term. It's basically the same idea as elimination. Like we would have just subtracted those equations to get a simpler one. So now this says x plus 2y plus 3z equals 70. I didn't really change that one at all. But my new bottom one here, no more has an x, so it's just 1y or y plus 2z equals 10. Okay, remember what we're trying to do is rewrite my x and my y in terms of z so that I can write out an ordered pair down below, or an ordered triple, I should say, and I want them all to have the letter z involved. So let's focus on this one first because it's easier. How do we solve this for y? Minus the 2z. So it would say y equals negative 2z plus 10. Okay, so here's what I'm also going to do at the very bottom. I'm going to just fill in my answer. So my y is going to be replaced with negative 2z plus 10. And my z term is just going to be z. I'm still missing my x, so I got to fill that in yet over here. So I'm going to leave a little space there. So now let's do that with this top equation. So this top one, I'm going to write, again, x plus 2y plus 3z equals 70. Right now I have 3 letters, but what could we replace the y with? Yeah, let's plug this in because then it gets rid of a variable. And that also gets you to just z's, which is what I want. Okay, because I'll be able to solve for x here. I just got to move everything over to the other side. But before I do any moving, let's distribute. So if you distribute that 2, what does it say? Good. And then I just want to solve this for x. So I want to move everything to the other side. So I want to move my z terms and my numbers. You might also want to combine things together. So like maybe you're seeing I can put this negative 4z and this 3z together. What would those become? Yeah, negative z. So you'd have x minus z plus 20 equals 70. So if you solve that for x, what's it going to end up saying? Good. And so I'm just going to fill that in down here. Z plus 50 would go in my y spot, or sorry, my x spot. That negative 2z plus 10 came from the y. And then z, like I said, for these is just going to be z. Any questions on those special cases? The only time you have to take it this far is if it's infinite solution. So if you get the whole bottom row to like 0 out, then you have to go this step. If you can't do that, like the very first one we saw where it was 0 equals a number, then it's no solution and you're done. Okay? All right.